right. Well, hi everyone. Thank you for coming. I always like it when I get the after lunch slot, because this way, if I suck, I can always blame it on people getting sleepy after eating. So I'll try to engage with you for a few minutes to discuss about Git workflows and how we went about in our team to experiment with a few strategies that I'm going to share with you today. First of all, this presentation is going to be more like a blatantly honest case study on how we tried to migrate from a centralized source control system, mainly SVN, to Git in a mature product development in a fairly big team, and the problems we encountered, how we tackled these issues, and a few things we learned along the way that I feel the need to share with you and maybe discuss afterwards about your personal experiences in this area. I'm not pretending stuff I'm going to tell you is universally applicable and that you're going to be able to use any of this. This is our experience, and you'll be able to judge how this fits in your team and in your projects. So to give you some context, my team works on Advanced Installer. You don't need to know about that thing. It's a 16-year-old code base under active development, about 3 million lines of C++ code, well over 100 Visual Studio projects. It's a Windows-only deployment application, and we do a monthly release cycle. So we've been working like this for quite a few years now. I've personally been on this team for 14 years now. And roughly the team composition looks like this: about 20 C++ developers, 5 QAs, 6 solutions engineers, analysts, 3 visual designers, and 2 technical writers. And I mentioned this because things we're going to discuss impact everyone on the team, not just developers. So we're discussing about a traditional SVN monorepo that's been 15 years in development, to switch it to a Git repo plus some submodules and change. How would we go about doing this? We started this journey about roughly a year ago. Well, learn the Git basics. All the cool kids know about Git these days, so it's embarrassing not to learn the Git basics. Evaluate your tooling options, of course. There are several options out there. Prepare a migration strategy for importing your history and evaluate your dependencies within the projects and submodules, stuff like that. The usual nitty-gritty details that need to be covered. And learn about idiomatic Git workflows. And this is where the problem gets really hairy. And the problem is that it's not the tools per se, is accepting change. And this is primarily a people's problem, not necessarily a technical problem. Because, as usual, people fear change. And any change that is disruptive enough will cause issues on the human side of things. So our team on SVN worked kind of like this. You can tell me if this sounds familiar to you. Mainly development on trunk for many years. Seldom featured branches, usually for experiments or some odd things we tried. Release branches for easy patching, of course, and tagging and all the good stuff. And, of course, an appropriate code freeze period in each release cycle, where we try to stabilize the main branch for release, of course. And we've worked like that for roughly 15 years. Recurring issues in this picture: imprecise planning and scheduling of features, of course. Feature flags necessary when we are doing this kind of single branch development. Breach of code freeze, of course. This is very frustrating, and it did happen a lot. And this is one of the main drivers we pushed for what I'm going to share today. So very frustrating and very painful feature change removal process in case we need to do a quick rollback of something that actually made it into the development branch and we're not able to patch it in time for a release cycle. This can be very painful. Not everything can be toggled with a Boolean flag. What we want, what everyone wants, is predictably deliver high-quality software on time. Sounds like a marketing tagline, but indeed, this is what we want. And of course, avoiding painful rollbacks. So a timid start in that direction is using feature branches, of course. This could have been done in SVN, but we decided to do it in Git because it's easier to manage branches in Git, much easier than SVN. So we embraced feature branches. But let's see how we went about doing that. We needed to make two important decisions: when to integrate changes into the master branch, and how are we going to integrate these changes. And being Git, there are choices. Firstly, let's discuss how to integrate changes from feature branches. And of course, there isn't one answer for this problem. There are various strategies to go about doing this. Each has its own advantages and disadvantages, and basically you have to try them out and see what works for you. There's plenty of information out there about choosing merging versus rebasing. Good articles and blog posts about this, ranging from beginner intro kind of tutorials up to nitty-gritty command lines and automation scenarios. So I've put quite a few links in the presentation. If you get the slides afterwards and you feel the need to read further about it, you can follow all the links in the presentation. So roughly, if anybody's not familiar with the two workflows, merging versus rebasing, it roughly looks like that. Merging is very close to the traditional centralized workflows that we were accustomed to, as opposed to rebasing, which basically replays all the commits and creates new history and gives you a more linear view on your repository graph. Of course, each one has advantages and disadvantages, as you would expect. For example, in merging, you have traceability, where you can actually see your feature branches, and they are long-lived, and you can actually see them grouped together and follow the development of a particular component and how it landed in the master branch. And on the other side, it has the disadvantage of creating a very messy history when the team size gets large enough, when there's a lot of thrashing and lots of experiments and lots of modularized development on various features. The history tends to be very, very, very hairy and difficult to follow sometimes. On the other side, rebasing, the history remains very flat, very linear. It's not very true to the actual development because the timeline has been rewritten. New commits have been created when rebasing. Sometimes this operation is accompanied by squashing of commits, and you don't have not always an accurate picture. But the history is very linear and easy to follow, and it's very easy to revert individual commits. And I mentioned earlier, squashing sometimes obscures things that happened in the past. You lose a little bit of context when you squash multiple commits together, and you lose the ability to see the steps through which the evolution of the change happened. It is more work. Rebasing is more work, let's be honest. Of course, you frequently need to force push at some point if you're rewriting history. And if you don't know what you're doing, it's easy to mess up your repository. That's true. I think everybody did some screw up in this area. That's how we learn. And coming from SVN, the natural choice seems to merge. And we felt that this was natural for us until we started to explore some more mature repositories out there, not some toy projects, that used this kind of workflow. And things turned up to look something like that. Lots of different branches, lots of crisscross. I even found a very funny project on GitHub that actually maps the Paris Metro framework with Git commits. So each commit is actually a station, and you have the junctions when you have the merges. So it's fully accurate. If you, next time you're in Paris, do clone that repo. It's very accurate. Okay. And the alternative, if you do not want this mess in your graph history, the alternative is embracing the dark side, so to speak. As an aside, any art history aficionados, does anyone know this Edward Munch picture, what it's called? Screen? No, you're wrong. It's called Git Rebase. We've been there. But in the end, we opted for this path because we chose a clean, flat history over everyday pain. Yes, maybe we're masochists, but we do like our clean history. And we went the Git Rebase route. And even in this scenario, there are various other flavors that you can experiment with in terms of tricks and fast forwarding and stuff like that. Now the other side, when to integrate changes in your master branch or development branch. So here we opted for an experiment, and we set out to tackle two strategies. I'll call them workflow A and workflow B. And we set out as a goal to experiment 6 months on workflow A and 6 months on workflow B. And I'm telling you the story now after elapsing this 1 year period. And what we found out in this experiment. Workflow A, first 6 months, it was very similar to our old SVN workflow because we wanted a minimal disruption. So we were a little bit scared at the beginning, too many changes in the system. So we opted for something that is smooth. We basically approved merge requests for the next milestone, let's say 4.6, and integrated them right away in develop or master branch, depending on what flow you're using, if you're using GitFlow or any other variant. Later on, we discarded the develop branch and stuck with master only. So basically, we schedule each feature or improvement, each merge request, and we decide, yes, we're going to schedule this for the next milestone. Very similar to our old workflow. We do our QA on the develop or master branch, as before. And bug fixes will have to come in multiple independent branches that will have to land on master as well. So there is a pain point here in that developers need to create several branches to fix all the issues that are discovered during the lengthy QA period. So drawbacks, like I said before, has all the drawbacks of the old SVN workflow, all the tedious work of creating branches for every little bug fix and integrating and waiting for the pipelines and integrating each and every bug fix, little bug fix triple branch into develop. Pretty difficult to pull back integrated feature branches in case of QA issues right before delivery, right before release. Usually pretty painful, same as SVN, so not much progress there. Develop master branch was not stable right up to the release day, so very late in the release cycle we would have a stable master or develop branch. And release day could be pushed days in case of late issues occurring, and we wouldn't be able to stick to our release cadence. And this is the exact thing we were trying to change. Workflow B, next 6 months, highly disruptive, of course. But it fits within the traditional agile models. And we work at pretty agile, or we would like to think so. So we're releasing monthly. QA on feature branch, plus lightweight integration testing. Bug fixes on feature branch, so no need for extra branches on the developer side. But this comes with a caveat of needing to rebase often. And approval of merge requests for the next milestone happens only if QA for this feature passes on time. So otherwise, the feature is slated for the next train release. Drawbacks, QA is on feature branches, like I said, so you do need some integration testing. Bug fixes on feature branch require rebases. We saw that this is not always something pleasant. If feature X doesn't pass its QA on time, you would end up with lots of long-lived branches, and this exacerbates the need to rebase, and you often need to rebase and fix the same conflicts all over again, because you have a long-lived branch, and you always have to keep it up to date with the master branch. And QA will pick up testing on a deferred branch that didn't make the cut for the next milestone. Will pick up the testing in the next cycle, and you would then end up with bug reports being shoved in developers' faces several weeks after they thought they finished working on that feature. And here's my colleague Gabriel there, who thought he was done with the development on a feature. And weeks later, some bug reports emerge, and he's facing a horrible rebase there. When to integrate changes? We're currently on workflow B still, but the experiment is far from over because we still need to learn a lot about this. So big shout out to my colleague Theodore, who basically had the attitude of we don't need to do any manual work if we can automate everything. So he did most of the work there to automate every step of the way and integrate all these tools and infrastructure, so we have some kind of streamlined experience. Just as a quick example, I'll show you a typical pipeline for us, some stages that need to pass validation from various build stages and automated tests and building a release candidate. The pipeline scheduler that does auto-approval of issues and synchronization of issue status in Ciura and updates, labels, and milestones, and sets the appropriate flags to be followed by the QA team. It's all done automated here. When QA approves a merge request, it has tested on the feature branch. It's just a matter of adding a label in GitLab, and the whole process starts automatically to automatically rebase the branch and try to build the pipelines and integrate it automatically. So there's no need for human interaction past the approval process of QA team. If a merge request is behind master, it will automatically be picked up by the GitLab robot and rebased automatically, and a new pipeline is triggered automatically. And if it finishes successfully, for example, GitLab bot automatically scheduled this for automatic merge. And of course, in case of failure, the appropriate people are notified via email and Slack channels and everything. And the process can be restarted again after the fix is pushed. And in case of success, the branch is automatically deleted, and the changes are replayed and rebased onto master. Usually the build pipelines looks like this, but it can look like this. And we have several servers taking all this load because we have several branches going concurrently, and the build pressure is enormous. And we have some pretty beefed up machines, but we do need more. So this is usually how it looks like from the inside, but it's all good. Tools and people. this is not just about tools and processes, rather about people, like I said in the beginning. And I want to thank all my colleagues for their willingness to experiment and for their patience and for their feedback along this process. And I'm curious to hear what's your experience. So do catch me after this. And if you're interested in talking more about this, I'm really curious to hear your story. Thank you very much.